Welcome! In this video, we will compute the change in specific entropy for liquid water as it warms from 273 Kelvin to 373 Kelvin at constant pressure. We will use the constant pressure specific heat, 4.18 times 10 to the 3 joules per kilogram Kelvin. Our goal is delta S, the change in specific entropy, in joules per kilogram Kelvin. At constant pressure, the change in specific entropy is given by the integral delta S equals the integral from T1 to T2 of Cp over T dt. If the specific heat Cp is approximately constant over that range, we can pull Cp outside the integral, and the result simplifies to delta S equals Cp times the natural log of T2 over T1. Here is an intuitive picture. Consider the curve Cp over T versus temperature. The area under the curve from T1 to T2 is exactly the entropy change delta S. We label the horizontal axis temperature T and the vertical axis Cp over T. We mark T1 and T2 and shade the area between them. This shaded area equals Cp times the natural log of T2 over T1. Now we will compute numerically using the simplified formula. Delta S equals Cp times the natural log of T2 over T1. Substitute Cp equals 4,180, T2 equals 373, T1 equals 273. First compute the ratio T2 over T1. 373 divided by 273 is about 1.3663. The natural log of 1.3663 is approximately 0.3121. Multiply by 4,180 to get about 1,304.6 joules per kilogram Kelvin. Notice the units. Cp has units joules per kilogram Kelvin. The logarithm argument is dimensionless because it is a ratio of temperatures, so the final delta S carries units joules per kilogram Kelvin. Therefore, the change in specific entropy is approximately 1,305 joules per kilogram Kelvin. Key idea: at constant pressure with nearly constant Cp, entropy change from T1 to T2 is Cp times the natural log of the temperature ratio. Great job!